Well, that's what the logic tells us. That's what the logic tells us. Therefore, step down a bit. Not quite sure how much. About this much. That's on the page. We're trying to prove that anything, if Andrew, I don't know, is related to it, then it, oh, that's a bit unfortunate, I chose related, then it is Bob's girlfriend. If I'm related to it, then it's Bob's girlfriend. Now if that's the case, that's the same as if and only if, anything at all, if Bob's friend is related to it, then it is Andrew's girlfriend. So if I'm related to something, then it's Bob's girlfriend. That's the same as if Bob's friend's related to it, then it's Andrew's girlfriend. Yeah, I'm wishing I had a different thing for G now. Anyway, prove that, given you know what you know about my friendship with Bob and our girlfriends. I'm going to change it to goat just to get around the whole, yeah. We own a goat. Yeah, that's better. The goat of Bob's friend is the same as Bob's goat. That's just going to be a whole lot less upsetting for people. No infidelity anymore. You're allowed to share a goat, to own it and to milk it. Nothing weird with owning a goat. Your mind out of bestiality. Okay, so this is an if and only if. So we prove the if and only if in the usual way. So we're going to assume the first part, try to prove the second part. Now, I'm doing something a little different than we've done before. Normally I'd go 4, 5, and then the other direction 6 and 7. I'm the other direction on the other side of the page because I don't know how long it's going to take. So it's just the two proofs side by side. I'm just laying it out next to each other rather than underneath, but it's exactly the same proof. There's nothing meaningful in that except page management. Okay, so we need to prove, given one of them, the other, and given the other one, the first. Okay. This is a universal, so that will come from universal introduction from yes, 8. We already used an A and a B, so we need to have a new letter. That would be C. Yes. Okay. Then C equals G of A. Yay, my girlfriend's got a name. Her name is C. That's an arrows our main connective now. So arrows are easily dealt with. Arrows, we introduce them. We assume the first part, R of FB, comma C. We try to prove the n bit, C equals G of A. If we can do that, then by 9 to 10, we've introduced our arrow. So now we've got 3 assumptions and premises, and we're trying to prove an identity. We prove an identity using our identity introduction rule. This will be a big block. We'll assume C and try to prove G of A. This is our big identity block. That's number 11. We want to try to prove that C is simply G of A. Ooh, I can see the mistake I've made. I'll explain that. Now, let's everyone find out for themselves. No, that's just me. Okay, we'll give you a bit more room at the top here. We'll cross this out, give you a bit of room here. You're going to need that room for something. Okay, we've got a big reasoning block here, 11, and some space at the top for things we might need to prove. Now, what do we know? We know that the top here we've got A is FB and GB is GFB. Now none of that's got C, so we can't do anything with C at this point. We do have G of A. There's no GA up there in any of these, but we do have an A. So that A can be turned to FB. So GFB goes, so from this line to this line happens by 1. And now I've got a GFB, which by line 2 is GB. So now I've got a GB, Bob's girlfriend. Now we haven't used for yet. For says if something's related to A, then it's Bob's girlfriend. That could be useful. Okay. Now we don't have an RA anything in here to use this arrow on, so we don't have something to put in there. We do have an R, F, B, and C. If I can turn this into an RA of something, I can use it on here. So I'm trying to get from this gap here from Bob's girlfriend to Chris. So I'm trying to do something to get more information. This will give me Bob's girlfriend to see what we can do with that. To get this, I need RA something. We've got an R of F of B of something. If only there's a way to turn F of B into A. Oh look, there is. So R of F, B, and C is the same as R of A, comma C. We change an FB to an A. Because I kind of have a plan of trying to link these things together. So that's from line 9 and 1 equals introduction. So this is still, yeah, so that's line 12. Now I've got an R of AC, and put the C into here for the X, and that will give me RAC implies C equals GB from line 4. Now I've got an RAC, and if RAC, then C equals GB. So I know Chris is Bill's girlfriend. And that's, of course, the thing I was hoping to prove. That's from 12 and 13. Oops. That was universal elimination. 12 and 13, arrow elimination. Now I've got C equals GB. I can use that to join between the GB that I want to prove and, fortunately, C. I just wanted a GB. It's given me both ends of it. So by 14, C is equal to GB. So that's from 14 and equals. So I should do a bit of manipulation and substitution in. My God, my handwriting's worse when it's bigger. So that's just C of A, R of AC. So to do some expansions out and then fill in the bits to be able to make my proof go that Chris turns out is not only Bill's goat, but also my goat, which is why it's goats, not girlfriends. Yeah.
There's a place I'm stuck.
Sure.
It's at the 12, 13. I can't get 13 from 12. How do you get 13 from?
So you get 13 from 4, so universal elimination.
Yeah.
4 says 4. Yeah, so we're just changing the X to a C.
Yeah, and what does 12 do?
12 gives you RAC. We got that from 9, and I did that so that I actually got to have something to go into here. That's why I did 13, so if I can get